Hey everyone, in this video we're going to create the perfect grass in Unreal Engine. We'll set up dynamic height control to make sure the grass looks perfectly mowed and learn how to achieve flawless trimming around objects. On top of that, we'll add realistic wind animation and adjust the color variation to make the grass look even more natural. For this tutorial, I'll be using a custom-made, optimized low-poly grass asset that I created specifically for my projects. Feel free to use any other 3D grass model, or you can download this entire pre-configured scene using the link in the description. To place the grass, I'll be using Procedural Content Generation. First, we'll scatter it across the entire landscape. Then, we'll create a perfect trim, so the grass doesn't grow on the concrete slabs, in the flower beds, or around the building. The result will look as if it was just freshly mowed. Before you begin, make sure the Procedural Content Generation Framework plugin is enabled. If it's not, activate it and restart the engine. In the content browser, create a new empty PCG graph. To place objects on the static mesh surface, I'll be using the Surface Sampler and World Ray Heat query nodes. Connect them. Add a getActorData node to specify the exact object on which the assets will be placed. Now drag and drop the created PCG graph into your scene. Adjust the size of its bounding box so it completely covers the area of your project where you want to place objects. For me, that's the entire plot of land. Let's go back to our PCG graph and activate debug for the Surface Sampler node. You'll now see colorful cubes appearing on all surfaces that have a collision. Note that the generation only works on objects with collision, so if your ground surface doesn't have one, be sure to add it. For complex geometry and high precision, use the Use Complex Collision as simple option. Right now, objects are generating on all surfaces with collision within the PCG volume. Let's go back to our PCG graph and specify which exact object we want to generate on. We need to assign an actor tag to the geometry that we'll use to filter the objects in the scene. In the getActorData node settings, find Actor Filter, World Actors. In the Component Selection tag field, set a tag, for example land. Now we need to assign this same tag to the ground surface. Select your ground surface in the scene and in the tag section of its details panel, add land tag to the actor section. Now the objects are only generating on the ground. To update their appearance in the settings of your PCG volume, click Clean Up, then Generate. Let's get back to a more detailed setup of the PCG graph. In the Surface Sampler node settings, let's adjust the point extents. I'll set the size to 16 for all coordinates, which is roughly the size of the grass segments. Next, let's configure the density by setting points per squared meter to 8. Our space is now filled with a dense layer of points. Now let's add a Transform Points node. This will allow us to control the size, rotation and offset of each object, making our lawn look more varied and realistic. Now let's switch the Debug view to the Transform Points node. To add some slight random offset to the grass along the X and Y axis, I'll set the maximum offset value to 2. For rotation, we'll set a maximum range of 360 degrees on the Z-axis. It's also a good idea to add a bit of size variation, from 0.9 to 1. Now our objects look more chaotic and natural. The main setup is complete, so let's add the grass geometry, disable the debug view and create a static mesh spawner node. In the Mesh Entries section, click Add Element. Expand the index, then descriptor. And in the Static Mesh field, select your grass asset. It looks great, but for now the grass is spreading everywhere. We need to carve out the areas where it shouldn't be. We can do this in a simple but not so precise way, by adding exceptions for the objects we want to exclude directly within the PCG graph. I won't go into detail on this method as it's not precise enough and won't give us the perfectly clean trim we're looking for. Using this method to achieve a perfect trim around the edges of concrete slabs will be difficult, especially in tight spots like this one. Let's move on to the most effective and quickest method for trimming grass around objects. This approach involves creating a mask map using a Runtime Virtual Texture. It will send real-time information about the location of the exclusion objects directly into the grass material, allowing for a precise carve-out effect. Before we start, let's take a look at my current grass material. As you can see, it has a standard setup for base color, specular, roughness, normal, mask and subsurface color. Now let's create our Runtime Virtual Texture. In the content browser, right-click and select Runtime Virtual Texture. Open the newly created asset. Here, we only need to change the virtual texture content. Since we'll only be using the base color, select that option. Save your changes. Next, add a Runtime Virtual Texture volume to your scene. Position and scale it so that it completely covers your level. Now navigate to the Runtime Virtual Texture volume settings. In the Virtual Texture field, select the Runtime Virtual Texture you just created. This texture will now be populated in real time with a map of the objects located within the volume's boundaries. As you can see, the texture is currently completely black. We need to tell the engine which specific objects we want to appear on this map. Now let's set up the material for our exclusion objects. In my case, it's the concrete material. Inside the material graph, create a Runtime Virtual Texture output node. Then add a constant 3-vector node. Set its color to white and connect it to the base color input of the RVT output node. Next, select the object in the scene that should be excluded. For example, this concrete slab. In the Details panel, find the Virtual Texture section and in the Draw in Virtual Texture list, select our Runtime Virtual Texture. Now all objects with this material will be rendered into our RVT. Here is what the result looks like. Now that we have our trim mask, let's set up the grass material to use it. In the grass material, create a Runtime Virtual Texture sample node. In its settings, select the Runtime Virtual Texture we created earlier. Connect it to a component mask node, making sure to select only the R channel. Add a 1- node right after that. Next, we need to combine this new mask with our existing grass blade mask. Create a multiply node. Connect our new RVT branch to the A input and your grass blade mask to the B input. Apply the changes and enjoy the result. We now have a perfectly clean grass trim around all of our objects. Now let's create the effect for trimming the grass to a specific height. In the grass material, create a local position node. Next, we'll need two scalar parameters, which we'll name max height and min height. These will control the minimum and maximum grass height. To get the height range, create a subtract node. Connect max height to input A and min height to input B. Then create a divide node and connect the local position to input A and the result of the subtract node to input B. After that, add a smooth step node with a min value of 0 and a max value of 1, followed by a 1- node. Finally, we need to combine this effect with our previous mask. Create a multiply node. Connect this RVT chain to input A and the new height control chain to input B. Let's set the default max height to 10, which equals 10 centimeters. Now you can control the grass height directly through the material instance. Let's set up a realistic wind effect for our grass. Open your grass material. Start with the absolute world position node, which provides world space coordinates for each pixel. This allows the wind to affect the entire landscape. Get XY coordinates. Then divide these coordinates by the wind noise scale parameter to control the scale of our noise across the world. Wind noise scale set to 60. Send the result to a panner node, which is responsible for animating the movement of our wind texture. Set speed to 0.2. We'll connect its output to a texture sample node with a black and white noise texture. Get a Perlin mask texture from the engine content. To make our wind animated, use a time node and a wind frequency parameter. Set wind frequency to 1. Their product via a multiply node controls the frequency and speed of the wind animation. We combine the result of the time node and our noise texture, using an add node to create a continuously moving texture. Next, to make the movement smooth rather than jarring, we add a sine node. It converts the motion into a wave-like pattern, creating a realistic swaying effect. To control the wind strength, add a multiply node and connect it to a wind strength parameter. Set wind strength to 0.09. This parameter will control the amplitude of the grass movement. To give the wind a direction, use a constant 3 vector to convert to wind direction parameter, which defines the wind's vector along the x, y and z axis. Set default value r to 1. Finally, to ensure the wind only affects the tips of the grass blades, use vertex color as a mask. Combine everything with a final multiply node and connect it to the world position offset output. Use name reroute node to connect the logic and keep the graph clean. Go to world position offset output and connect our wind reroute node. Save the changes and let's check out the result. Everything is working perfectly. We can now control the wind parameters directly through the material instance. Now let's set up the color variation for the grass. Navigate to the material settings. I've added 2 grass textures, one with green grass and a second with yellowed grass. For the green grass texture, add a multiply node and a constant 3 vector. Convert the constant 3 vector into a parameter named base color green tint. This parameter will control the tint of the green grass. Set default color to white. For the yellow grass texture, create a power node. Convert the exponent input into a parameter named base color to power and set its default value to 2. This will control the saturation of the yellow grass. Next, we'll blend both textures using a lerp node. Connect the green grass texture to input A and the result from the power node to input B. Convert the alpha input into a parameter named yellow grass intensity. Set default value to 0.3. This parameter will control the intensity of the yellow grass when blending with the green. Now let's create the logic for the variation itself. Add an absolute world position node followed by a component mask where you select only the R and G channels. After that, add a divide node and convert the B input into a parameter named variation scale. Setting its default value to 2000. Next, add a texture sample node and use the standard Perlin mask texture from the engine's content. Using a lerp node, we'll blend the green and yellow grass with our new chain from the texture sample acting as the mask. Almost done. The last step is to create a named reroute node and name it base color. Now let's connect our base color reroute node to the base color input before the main saturation and brightness settings of the material. I'll also duplicate the base color to the subsurface color output to enhance the variation effect. For subsurface color, I already have a simple setup for controlling brightness and saturation. Now open the material instance and let's see how easily we can control our grass's color variation. Now you can control the scale of the color overlay and the intensity of the yellow grass to achieve the perfect look. You can download the project's source files using the link in the video description. See you in the next video.